Welcome to another episode of the Ron and DaRon podcast show. I'm DaRon.
I like that phrasing, likely cut and paste mistakes. That's
Yeah, actually, so if you want to take a look, what we're doing here, they call find view by ID here. You'll notice it's a view. They call find view by ID on the same exact object, and now they're casting it to a button. And yes, this was a view button, but this is a button. So
yep,
when we see stuff like this, it begs a lot of questions about how you have this object that we're sucking in and what it is you're trying to do. But it is probably a copy paste error. And interestingly enough, I mean, just looking at this, it lets us stumble upon this right here, right? So we can see what that is. I think we both recognize this is base
so
64.
yep,
So definitely something that we would want to decode just to see what all is going on there.
yep, yep. I have to say, I'm always a little bugged when you're seeing a variable that's enc under solid data, something on that lines,
I
because
know.
is it encoded data or is it encrypted data?
Yeah, you're exactly right. Interesting. We'll set this to auto detect. So no printable characters found. This thing says it's all binary junk. But
Yep.
to exactly your point, so what we could do then is pull up all instances where they're grabbing from ENC data this string, and then from there we'd figure out what they're trying to do. They have this code here which gives up the ghost because it's telling us they're going to decrypt. So we know it's base 64 new string, and then they call operate. Let's take a peek at what operate does. Ah, so it's just a basic shift. Okay, so what they're doing very basic bit manipulation. This I mean, technically it's encrypted, but not really. It's just a basic XOR, exclusive OR to pull the results.
Look, if you don't have the key, that's well, going to be a bit tricky to do, except in this case, if you know enough about the data, you can still derive that key because it's not complicated.
Right. Okay, that's a good point. And actually, I do want to use this. Let me do this right. So one of the beautiful things about this is what we actually found was just glancing through here, through this code that it pointed at. We saw, I mean, just I've told you before, I believe, Logan, but whenever I see anything like this commented out code, I immediately become very interested, extremely interested. And it was, it is in this that we stumbled upon this whole bit where we're encrypting data, decrypting data. And through that, by looking at this encrypt decrypt class, we see number one, how they're doing this, which is just basic exclusive OR. And number two, we can see what they're doing right here with this hard coded secret. The hard coded secret is a vulnerability that comes up time and time and time again. It can be hard coded user credentials, it can be hard coded keying material like this, it could be a hard coded key itself. If we were talking an RSA key or what have you, having that hard coded in and of itself is a finding. And one of the most common questions that I hear from development teams who are unfamiliar with this kind of thing is, okay, we understand this, but what's the real vulnerability here? And I always point out you have a few different vulnerabilities. First and foremost, we have an issue where if a developer is let go and it's under unfavorable circumstances, unfavorable in so much as either one, they just leave, or two, we have to get rid of them. Maybe they were sexually harassing someone. Maybe their performance was weak. Maybe it doesn't really matter. Even if they leave of their own accord, it's very easy for a developer to purposefully or accidentally or help desk to give up this secret, to post this online. I've seen help desks trying to debug issues and accidentally give away hard coded credentials. And now it's very difficult to fix that problem. It's incredibly hard because I have to update this in my code, get it compiled, and then get it distributed.
And for the added fun, if you've hard coded it here, what are the chances you're hard coding the same secret in other applications?
Exactly.
Uh, for example, as I have seen, certain strings that start with AKAQIA, or as other people might recognize, Amazon credentials.
Yes.
Well, th- those I've seen them be frequently used and hard coded in code. And oh, by the way, guess what happens if somebody has a look at your code repository?
Yes. Yes, that's exactly right. You're spot on. If your code repository gets compromised, a la SolarWinds, for example, or anything of that nature, and it could just be that you accidentally make your code repository public. I mean, that happens all the time, especially since so many organizations have shifted their code up to GitLabs and GitHub and other similar code repositories sitting up in the clouds, or they're putting it in, heaven forbid, SharePoint or something like that. I've seen that, or OneDrive, and they accidentally share it, or someone purposefully shares it but doesn't realize the impact because they don't know that there's hard coded data in here. A whole host of things. And we actually had a discussion just recently with another group, and they were talking about how the hard-coded credentials that we had found were actually used in other products. And this is exactly to your point. So when we pointed out these hard-coded credentials, it was okay. Well, let's say someone doesn't get your source code, but maybe they get source code that has those same credentials, and someone puts two and two together and realizes that it's the same general company making this code. So let me try this one. Bam, they're in and away they go. I think it's also important that obviously this is a particularly short secret, and the way this is actually written, it would be incredibly obvious if you have any repeating characters. This is very susceptible to a number of actually cryptographic analyses. So
Yep.
this is
Plus,
bad.
you have the fun of this is a public class with a static public variable.
Yep.
Uh, what happens if somebody changes a secret on you?
Yep.
Or for more fun, what happens if somebody changes your secret length on you, but not the secrets?
Yes, I'm glad you went there because this is actually something I was going to get to. And you probably noticed my IDE was already complaining about all of this stuff. It's going through and it's saying, okay, so first and foremost, I've been asked before about the unqualified static field access. And we discussed previously, this is so that I can see when someone doesn't realize they're calling something that's static. This is something so that I can see when someone intends to call an instance variable. That's also why whenever I program, part of my coding standards say, thou shalt always do this dot for variables, for class variables that are non-static. And for static, you shall always go through and do the proper qualified static field access because you're spot on. If this gets elongated, let's say you were to make this amazing application, okay, but if it gets elongated after this has been set, and remember, it's a static, so unless you change it, the second this class is initialized. So the second this class starts to come online, either as through a static reference or as an instance, these two guys are set. And the compiler, the runtime is not going to change it unless you physically change it. And you are exactly right. Neither one of these are final. Neither one of these are read only. They both can be edited. So I can have an instance where we have an array out of bounds exception because of what we see going on in here. Because we call to secret.char at, but the secret length is shorter than the actual, or sorry, is longer than the actual secret. If the secret length is longer than the actual secret, we'll see an array index out of bounds exception. And it's going to crash all day, every day. So that's not great. But if secret length is shorter than the secret, then I'm not even getting the full protection, so to speak, of the secret. So this is bad. This is also vulnerable to race conditions, right?
Yep. Again, you could be in the middle of things and maybe say they change.
Mm-hmm.
Well, we are looping, so well, they change. It's going to pick up the new value, and now we have some really weird stuff happening.
That's right. It's not going to decrypt properly. It's not going to be encrypted properly, but it won't decrypt properly. It doesn't matter what you try doing to this thing. You'll never get the full message anymore. It, this is such a funny, strange, poorly done, and I don't know if they did this on purpose. I'm going to assume the public was on purpose for demonstration purposes. I'm going to assume read only was on purpose. I don't know about this though. Setting secret length to secret.length. I don't know if that was intended as an Easter egg or not. It'd be funny if it were. But but this is actually a common mistake. And of course, I'm sure you know why. You'll have developers that say, well, it's static, it's not going to change, which isn't how statics work. But
Nope.
it's static, it's not going to change. Let me only compute this once because they think this is heavy. Now, I'm sure you remember in C Sharp, languages like that, C++ for that matter. Is it computationally intensive to get the string length?
No.
Because they maintain it, right?
It's part of the thing.
That's right. That's right. This isn't like C, where it's going to go through and say, oh, wait, I have to go through and count until I find a null. No, like you said, it's part of the
Yep.
thing. So
Yep.
there's honestly really no real point in this. However, I understand why they do it. It's just since this is mutable and this is mutable, it's a bad thing anyway. I mean, it shouldn't be mutable, but there's nothing good about this. And order matters with statics.
Yep.
Order matters immensely. So we have a lot of problems going on here. We have a lot of problems. Now, I will say something I always like to do, and you've seen at least some of my code, I believe. You probably noticed I will final even variables inside of here. And I do actually have, for me, that's a coding style thou shalt. If you don't intend to modify a variable, make it final. Even if it's a method variable, make it final. Even if it's a parameter, make it final. Because, as you know, in a language like Java, all of this is up for grabs. And I want to make it clear that my intention is I want you to change this. And by having that default of thou shalt make it final, then it makes it so when I'm looking at this code here, I can say, hey, this is expected to change, but I don't see us changing it. We're not updating it in any way. Now, obviously, in a simple example like that, we can all see that the programmers just didn't have it. But if we were looking at a complex example where we have a bunch of if-thens and some loops and some other craziness, it may be that I intend for something to change that never gets updated. And we actually have checks for that in here. And that's where I can find some really weird bugs, really hard to find bugs is things like that. And so this is just yet again one of the beauties of having all of these IDE checks in here. I mean, even something as simple as missorted modifiers. If you have standards that say thou shalt always do public static void main string args, yeah, that's right, you heard me, in that order, then you know it's easy to find that code that doesn't smell right, that code that looks bad. And all of this is actually in here. Every single thing in here is actually displayed down in all of this rigmarole. But I actually want to go to something maybe interesting that a lot of people might miss. Let's see if I can find it. Let's see. I actually did not run this before, but I did take a quick gander through their code. Okay. So this guy here. So we see it's keying in on, it's complaining, hey, we have an equal equal on a string. Now, more specifically, what it's really saying is on two objects. We're comparing two objects through double equals. Now, this isn't a test, I promise. I just don't want to be the one who always talks. So what do you see? What's wrong with doing an equal equal on an object?
Well, in this case, you don't know the type, so you're going to end up with the potential for type coercion issues.
So what you're describing is a very, very nuanced issue. Incredibly important issue with a lot of high-level languages and scripting languages as well. Now, at first blush, someone might go through and say, what is this man talking about? It doesn't do type coercion. There's no type coercion. This is Java. And they would say the same thing if this were C#. And they would actually be wrong in this case because C#, Java, etc. will try to coerce data into a string through toString. And that's going to result in some wonky behavior. On top of that, what people need to remember is with a language like Java, for example, equal equals on an object doesn't compare the values necessarily. It can. It's much more complicated than that. But what it typically will actually compare are the addresses of both. So if isAdmin actually equals true, this actually might return false. And the reason why it might return false is because that true isAdmin is pointing to a different address space than this true, the string. And this is where it gets even more complicated. This whole thing will make your head explode until you figure all of the wonkiness that goes on out. But the way C#, Java, etc. work is they use caches extensively, right? They use caches for integers. They use caches for strings. There are actually a few different object types that they will use a cache for. But those caches are limited, or to steal from you, caches. Those are limited. They're limited in size, and so I can have two strings that are the value A, B, C, D, E, F. One sits in the cache and the other doesn't. The address spaces wind up being different. Now, the runtime environment may recognize that this data already exists in the cache and may point it to the cache's address space, or it may not. We can't assume that it will. And so what we wind up seeing is, as a direct result of all of this, we get inconsistent behavior where something can be false, but where the value may be false for isAdmin, but it actually evaluates here as true because the address that false was pointing to happens to be the same address for true. Or where it's true, but this conditional evaluates to false because the two truths are in different address spaces. You can get the world's strangest, absolute strangest behavior from all of this. But you're exactly right. On top of all of that, we have that coercion even inside Java, where people forget that coercion exists. And that goes to a different finding, which of course is auto-boxing and auto-unboxing. And that's where conversions go really loopy, really, really, really loopy. We talked about a little bit of that before, but just looking at this, I definitely see where we have a vulnerability and we have a bug. And that's so very common. And it's the same thing. It's just how you know, tweak your glasses. That's going to dictate everything.
Yeah, I suppose it's also the other fun vulnerability there, in that we are decrypting all of this, presumably using our highly secure encrypt decrypt from JSON. Well,
Yes.
that's usually a sign that you're passing this data back and forth, so you can just, edit the JSON object, and hey, you are now admin. Congratulations.
Yes, yes, you're actually right. If we were doing, to exactly your point, if we were doing an assessment, what I'd be doing is I'd be marching up this stack. Now, we can see we have a lot of data in here. This is apparently a response. We are taking and decrypting data. I I would I would definitely spend some time looking at how they're doing this. Number one, because we've already seen this decrypt method. We've already seen what's entailed there. We're not particularly enthused. We know that someone could figure out that the secret is amazing. We also know when we looked at this that some of this code spits out to places like this. And this in and of itself is an issue because anything that's being printed out through this means is going to get caught in our general system logs. It's also going to be pumped to a console. So if this is running inside of a console, it gets pumped straight to the console, but it will also get collected up by the system logs and things of that nature. So you have a huge potential for sensitive data, boatloads of this ciphertext and other stuff being pushed to the console, and obviously that's going to wind up being a vulnerability in and of itself. And I recognize that a lot of organizations get touchy about things that are physical, but it is important to remember that anything that goes to the console goes to the logs, and the logs are typically not well protected. So we see the same general issue right here. So we have ed.getText.toString. This actual toString here is pointless to exactly what you were saying, Logan. It's going to toString it itself. We see not equals. This runs into the same exact issues as the prior one. It's the same general vulnerability. They're trying to check that the value isn't an empty string. They're setting the empty string twice. I'd create a constant for it because it's more efficient. I like we've discussed before, the doing something like not equals or any of the inversions is typically a bad idea because it's very easy for someone to come in, not understand what this is doing, try to flip things and screw up the inversions. Or, not notice that this is a not equals and accidentally make it an equals. All kinds of bad things can happen from a maintainability perspective. You see it's complaining about this extraneous toString. Uh, Obviously, it's not necessary. I don't know why they would do this way. Get text is in and of itself already going to get coerced into a string. They're parsing without verifying that it's in fact a string, and then they're catching JSON exception, whereas parse int will throw an exception of its own if this is not an integer, and they're not catching that. In fact, I don't see them throwing it either.
Yeah, they're also, yeah, sorry, no, parseInt is not the one that gives you the value separately from the whether the operation was successful or not. That is try parseInt.
Correct. Yes, that's exactly right. And this is
Yep.
just going to throw an exception until you're blue in the face. See right here, that number format exception. So if you give this thing
Yep.
something that's not an an integer, it's just going to. If this is null, if get text is null, which they never check the nullness on, then we're going to throw a null pointer exception. So if they didn't set it at all, there are a lot of big things that are going on here. I don't like how they have the endpoint hard coded like this in here. I again, I'm just glancing at this stuff just now. I actually don't like how they're getting the JWT either. I don't like how they default to null with received token, because that risks null pointer exceptions, and I don't believe they're checking for nullness on this, and they misspelled this, which bothers me. Not even sure they. Yeah, so they don't check nullness, so it's going to print out bearer null if it were null before. That it's just this whole code reeks of not being well written. Actually, the way they're doing this map in and of itself isn't good, because they're returning a very immutable map here. So anyone who gets this can now modify the headers, which we don't want. Actually, it's something we went over. God, there's so much. They're logging here. They're logging the decrypted response, which means you're potentially logging sensitive data. If someone, again, gets a hold of those logs, because we are logging the ciphertext, but now we're also logging plain text, they could easily, without your code, figure out what your secret is, especially because it's so short and easy. They could also figure out your algorithm, and they could steal the JWT or what have you and do all kinds of bad things.
There is a reason why chosen plain text is in fact an attack
Yes.
on a lot of different encryptions.
Yes, that's very true. That's very true. I like looking at these parameters. So request data, put to account amount, and then they go through and they encrypt it. And this goes exactly to what you were talking about, where we have the potential for people to decrypt these and then forge packets. We have the potential for someone to not even decrypt it, but just start spamming out stuff, because one of the beautiful things, they don't do any error checking of any kind here. So I can figure out, using your exceptions, what your secret is, very much in the exact same vein as a padding attack. In fact, exactly in the same vein as a padding attack, just running through this.
I suppose you also have the other fun side of you're not using any sort of user specific salt
Yes.
or any sort of salt at all. So if maybe let's say you can't figure out what this is, but you can just copy
Yep.
paste and trick people into making edits or doing whatever it is you want to accomplish with this,
Yes.
and it will be happy.
Yes, you're exactly right. If I, in fact, I could even use the Oracle against the application itself. To what you're saying, I steal that token. I then march around with that token, and then I will be able to figure out when the user interface or whatever displays the plain text from that token. Because undoubtedly, this application is going to decrypt it and then display the different portions. And the second they do that, and we know that again based on what is in here, the second they do that, I can modify that plain text just a little bit, send it, analyze, hey, look, here's how the token changed. Okay, now I figure out the algorithm. Now I figure out the secret. And I know I mentioned this before, but because the secret is so short, this means that you're going to be encrypting with the same letter in the same pattern over and over and over again. Frequency analysis is going to find this all day, every day. There's nothing about this that happens to be particularly great or secure. So, all right, let's move on. I know that we could take a peek at this one. I don't even know what it does, but I don't even care what it does. Reference check for null is not used inside. So what we're interested in with something like this is we have extras. For whatever reason, again, I haven't looked at this code at all, they're checking nullness on extras, but they aren't actually using extras in here in any way, shape, or form. Nor do they seem to be using it in here. So when I see code like that, I ask, well, what is it about extras that they would be interested in? Interestingly enough, for this one, it loads the URL from this get token. So we grab URL from the intent.data, obviously you're going to have a problem in that if someone sets URL to pizzahut.com, this thing is going to load pizzahut.com. If they set it to some malicious site, it's going to load whatever that malicious site is. So what this is actually really doing is, if they don't have any extras set, then they assume that that URL isn't set. If extras are set, they assume URL is set, which does beg the question, what if URL isn't set, because they're not accounting for that, and you get a null. And this also would tell me I don't have to just point to pizzahut.com. I could point to your FTP site. I could point to SCP. I could point to anything. So you risk someone doing something especially bad through this mobile application, using the mobile application to pivot into your internal network, for example. Well, that's it for today. I hope you all enjoyed, and please like, comment, subscribe. If you have any questions, comments, concerns, let us know. Thank you, Logan. This was at least fun for me. Hopefully it was fun for you.
Yeah, it was fun for me as well. Thank you for inviting me.
Have fun.